How did Ranty debunk the flat Earth? Elegantly. He made a 5 hours trip to the Great Orme in Wales, to an elevation higher than the wind turbines that he intended to shoot. The turbines stand at 98 meters tall, and the location height is around 121 meters without adding his own height. So, as the flat Earth claims, the horizon should be at his eye level, and the turbines should be well below that by over 23 meters. But that's not what we see in his video. He showed the horizon drop elegantly and even better than many Glober's attempts. But if flat earthers believe that the Earth is flat, there's gotta be a way out of this. And the only way out is fog/haze. So the other day, Gleam showed me a similar image to this one, where we can see a clear-cut horizon, except that it wasn't. It was a distinct starting of fog. So the claim is that the real flat Earth horizon is obscured by fog, and that fog is creating another closer horizon that appears lower in our field of view, mimicking the horizon drop on a globe. But there's two reasons that can't be the case. One, excluding the distinct moving fog wall, we should observe opacity gradient starting from our feet and out into the distance. But that's not what we see in this video. We don't see any gradient in that opacity. So the second is assuming a wall of fog that is circling the observer to give him the impression of a globe. There's still a way to determine the horizon, even if that's the case, which is by taking note of multiple targets at various distances sharing the same conjunction of the sky and water. So as you see in this example here, I presumed an ocean and sky that having the exact same color, and I have here some ships that they are the same size, but they are, you can of course conclude the distance that they are so far. This one is further away than this one and this one, but you see those three are almost in the same line. So at that point it doesn't matter if I added fog, as long as I can determine that I can see that ship on the same level like that ship. So that means that this is the horizon. Doesn't matter at that point if I see the sky or not. If I see more than one target at various distances at the same line, that is the horizon. So, can we find something like that in Ranty's video? Yes. And many thanks for Ranty for panning the view slowly and showing us a lot of marks that we can use. And here is the first target at 40 kilometers. This is the Bar or Mersey light vessel. This is where I get the distance from, and of course this is the location where Ranty was shooting these observations. Is this his car? I'm not sure. I hope I'm not doxing him. So that's the first one. It's at 40 kilometers. This is the actual image of this light vessel. It took me a while to find it, but I'm glad I did. And the second one is this kind of platform on very tall legs. This is taller than usual. The first time I saw it, I thought this could be, is that like what do you call it, stretching or towering or looming, but actually it's not. It's a target at 37 kilometers, and it's the platform of Hamilton Linux. This is one of the network of the Douglas complex, and you can see the resemblance here. And of course, here's the distance in nautical miles. I just translated them into kilometers here. The third one is this target. If you can see it, let me zoom in. And I think you can already know what is this. This is the Douglas complex at 29 kilometers. So these are 3 targets. All of them are on the horizon. The same line, different distances, somewhere between 40 kilometers, 37 and 29. They're all sitting on the same line. So doesn't matter if this is clouds or this is fog, we can see these targets are sharing the same line of the horizon. That's the horizon. And as you can see here in this image, the wind turbine is higher than this horizon. So, ladies and gentlemen, Ranty, in collaboration with me, but of course I'm just the smaller job here, I'm giving you the horizon drop. And thank you for watching.